Welcome back to part 3 of the GeoPy Advanced workshop. After scripting GeoDict programmatically and performing automatic material optimization, we now want to elevate this to the next presentation step. In this part of the workshop, we're going to be talking about how you can create custom PowerPoint reports from your simulation results. Note that you can do this even though we're using Linux-based virtual cloud machines. We have installed LibreOffice on the machines to be able to glimpse the workshop results, but to create other PowerPoint templates and see the results of their full extension, you will have to use your own PowerPoint installation. Since GeoDict 2020, we've included a library to create PowerPoint files. We have done this with the general idea that you start with an empty PowerPoint file, which only contains slide masters, which can, for example, include your corporate design as well. But the most important part is that you have predefined slide masters, and you can then, if you want to create a slide, just pick a master layout. So for example, if you pick the master slide, which corresponds to the layout of the slide you want to generate, then you see these placeholders where it actually says in PowerPoint, enter text or something. And you then go and replace those placeholders by actual content. In our case, we'll identify placeholders by their placeholder text. In our example here, you can see a master slide which has a title placeholder, a picture placeholder, and a picture caption placeholder. To illustrate how it works, here again we see the master slides, or rather we have the one master slide. We have several layout masters as they are called in PowerPoint that you can see here. This master slide actually doesn't matter. But what is important is that we have these layout master slides that you can define yourself. You can design them as you wish, or probably you already have master slides with your company logo and so on. But the most important thing for us, when we want to programmatically access them, is the number. We have to be aware that the master slides start numbering by 0. The first one that you see, the first layout master that you see below the master slide, is called layout slide 0, followed by 1, 2, 3, 4, 5, etc. So when you want to generate a slide, you go to PowerPoint, you open up your master slides and you check which slide you want to use, and you count the index of that slide and will write that down basically. Here in this case, we have picked the layout master slide 1. You select this master slide, you give a title from within Python, you give a picture, and you give the picture caption, and this generated slide to your presentation. You do this one by one until your presentation is completed. Using Python code, we have replaced the title here by the text, this is the title text. We've replaced the picture by a concrete PNG picture from disk, and we've replaced the picture caption by, this is the picture caption. So next I want to show you how you can do this yourself. So let's get started with our hands-on part. Please go back to GeoDict. First of all, please change the project folder. We have already prepared a folder which has some example files. Go to File, choose Project Folder, select Project Folder, and go to the root of our workshop materials. Here you can see, next to the project folder that we have been using previously, we also have a folder called PowerPoint Reports. Go in there, so double click and click Select Folder. Next, I would like you to go to Notepad QQ, hopefully still open on your machine, and create a new file. You can do this by doing File, New, and save it as, so File, Save As. Go to the same folder, PowerPoint Reports, and save it as ppt1.py. So what we are doing now is, we are writing a Python macro basically from scratch. It will not have the header, the description, or the variables block, which are basically GeoDict specific extensions. But it doesn't matter in this case, GeoDict will happily accept it anyways. We start by doing import gd_ppt. We are actually using a well-known library, which is called Python pptx for this, but we've found it to be too complicated to use. So what we did is, around the library, we wrapped our own library, which makes it a bit more simple to use and which allows you to basically use the scheme that I described earlier by taking a master slide and replacing the placeholders in that slide. We found that to be a bit more easy to use, and yes, they are both independent of running under Windows or Linux. But you can always use the underlying pptx library directly if you want, if you need more powerful constructs, for example. So we start by creating a report generator. So rep equals gd_ppt.report generator. Note that capitalization matters here. So it has to be a capital R and a capital G. In quotes, ppt_template.pptx. The reason why I asked you to change to this other project folder is we have this ppt_template.pptx there, which is a PowerPoint template file which contains some master slides, namely the ones that I showed you earlier. We create a report generator which uses these master slides basically as the source for the layouts that we can use. Now what we want to do is we add one single slide. We do sl equals rep.add_slide and we select the template 1. So that is basically the second template slide below the master slide, the second layout master slide. We pick that. Now we start replacing individual parts of the slide. So we have sl.add_text in brackets title. This is the title text. This title is what you saw in the layout master slide. You actually have to give it some keywords so you can address this from the Python code. Normally it says put some text here or something, so it does not have any meaning usually. But here you have to give a keyword basically in your layout masters, and this is what will be used to address these individual design elements from within Python. So in our template it is title, picture and picture caption. These are the three elements that we need to replace. Let's go and finish that. We added our text. Next, we want to add the picture and the placeholder. It is called picture as you saw, and we replace this by example.png. This actually has to be an image file that has to be on disk at this point in time when it arrives at this line. But of course, we saw earlier that you can create an image and write it to PNG file. So we include the relative part to this previous location by including ... project folder / prior to example.png. Of course, nothing stops you from here creating multiple plots and then taking these files and inserting them into a slide. But in this case, this example.png is a file which we have already prepared. So in this directory that we changed to have this ppt_template.pptx, we have the example.png as example file. Last but not least, let's add the picture caption. So add_text in brackets picture caption, and this is the picture caption. Now this slide has already been added to the presentation at this point. We have filled it by replacing all placeholders, and now finally we only need to save our presentation. So we say rep.save and we call it in brackets example.pptx. Sorry, I forgot that we are using a virtual cloud machine. We have a major difference between Windows and Linux at hand here now. Folder separations are done with slashes, not with backslashes. So please go back up to our relative paths and change the folder separators accordingly. Of course, you could be adding more slides here. You could go again and write SL or SL2 equal rep.add_slide and even use a different layout master if you wish, and then replace the placeholders of this slide, etc. as often as you want before saving the presentation. Now save this file. Now let's go to GeoDict. Open the macro execution dialog. So macro execute macro /script. Now you should see that a new Power project folder should be listed here, namely PowerPoint reports, and unfold it and click refresh if necessary. And there you should see the ppt1.py. Select it and click run. This is a very quick operation. Now we go to the File Explorer. We go again to the base of the workshop materials. Here we have PowerPoint reports. Here we should find example.pptx. If I open this, even though it is not native PowerPoint here, you can see the slides that I showed you earlier. Python has programmatically replaced the title placeholder by, this is the title text, literally, and likewise the caption, and it has replaced this picture placeholder by the PNG file from disk. Again, let me show you the master slides in native PowerPoint on my machine. Here you can see them again. You see the master slide, which you do not care about in this case. and the layout slide 0 followed by the layout slide 1. If you remember, this is the one we used with 1 in brackets. Here we replace the title, picture and picture caption. The actual template file that we were using is actually and just basically an empty presentation of the same type as this presentation, which only contains the master slides. Now before I close this presentation, let's have a quick look at a certain master slide that I want to use in the next step. So I go to the slide masters. We're going to be looking at slide number 7. So this is 0 again, 0, 1, 2, 3, 4, 5, 6, 7. And here we can see that we have a title, a table and a picture. And in the next step, we are basically going to fill out this slide. Now remember that in the file workshop5.py, we were plotting the permeabilities against the SVP and added binder. We now want to create a report slide based on that. We go back to Notepad QQ. We start by opening the workshop5.py. So go to File, Open, and go to the old project folder, which was called Project Folder, and open the workshop5.py file. Again, if you were not catching up, you can also take our version of workshop5.py, which can be found in the M2M result folder next to the project folder. We have workshop5.py. Now please save this as File, Save As, and now back to the PowerPoint reports folder next to the project folder and save it as ppt2.py. Now we can fold this function again. Here we still have our code which produces the image and saves it as permeabilities.png. Now we just go to the very end of the macro and we continue import gd_ppt again. So we get our PowerPoint library. Again, we write rep equals gd_ppt dot report generator. So again, we create a report generator object. Again, based on ppt_template.pptx, use the same template slides. Then we use the shortcut SL for slide. Use SL equals rep.add_slide. But now we are basing it on slide number 7, as I mentioned earlier, which has a title, a table, and a picture placeholder. We begin by replacing the text for the title. So we do sl.add_text in brackets title, and we write flow permeability versus SVP and binder, because this is what we want to show in this slide. Then we can already add our picture because we have already produced a picture in the code above. So add_picture and replace the placeholder called picture by the concrete PNG file permeabilities.png. Next, as you can see in the layout master, there was also a table placeholder, and that table is going to be a tabular representation of the permeability versus SVP and binder. But we need to construct this first. So we start with table_data equals list, empty list, and this is going to be a list of rows basically, of table rows. Note that each table row is its own array, which we must construct sequentially. So we start with an iteration for SVP, covering values in range, in brackets length, in brackets SVP values, and use a temporary variable called result equal empty list. Then add a table row with SVP value and permeabilities for all binder options. So first, the SVP value, write result.append, opening bracket, with the string conversion of the element SVP values of index. Then include a second iteration over binder indices. So for I_binder in range len binder values and append all its elements to result. Here we use an f string to truncate the floating values by putting the variable perm_values I_svp I_binder with the format ::2e in curly brackets. This is another construct I showed you earlier, the format string, which allows you to replace some parts of a string by a variable value. This is special syntax, which allows us to specify how numbers should be formatted. In this case, it means format the number with 2 decimal places in exponential notation. If we do not do this, we get very long and clumsy strings of digits, which are hard to read. Now we're going to add the header of the table. The horizontal header is an empty list at first. It consists of the first column, so we append SVP first. And then it requires the binder values used. So we iterate over the binder values again. For eBinder in range len binder values, we append the string conversion of binder values of iBinder. Next, we're going to replace a table placeholder, which is the last placeholder on that slide, using sl.add_table. The placeholder is called tabled. We replace it by the table data. We can also specify a horizontal header here, so add horizontal header. We have replaced the three placeholders, the title, the picture, and the table. And now we can save our presentation. Again, it is just a single slide in this presentation, but of course, it can be easily extended. So we save this as, let's say, plot_and_table.pptx. Again, we use rep.save and include this name. Now let's hope we do not have any typos and save this file. Go back to GeoDict, execute macro/script. Refresh if necessary, and select the ppt2.py and run it. Now we go to the Explorer. Go to our PowerPoint resource folder, and there we can see plot_and_table.pptx. You can open it, and it looks like this. Well, at least in native PowerPoint. LibreOffice may have small design differences. But you can download the result pptx files from your virtual cloud machine and open the file with your local PowerPoint. Here you can see that we have rendered the plot and inserted it instead of a picture placeholder. We have taken the same data and inserted it as a table with a horizontal table header. You can change the layout from the slides by just changing the master slide. For example, you could swap this around in the master slide. Just run the same Python script again, and the table will be on the right-hand side and the graph will be on the left-hand side. So even someone who does not know anything about Python programming can change the layouts just by modifying the master slide in PowerPoint. Now let me give you a short overview over the supported content types, so the pieces of content that you can place into a PowerPoint presentation. I will show you these slides, but note that this whole slide deck is included in your workshop materials, so you can use this for reference later on. You have already seen the SL add text function, which replaces a placeholder by a given text. One thing you have not seen is the optional argument called font size. So here you can experiment with different font sizes, and depending on what number you specify here, the text will be larger or smaller. Add picture we have seen too. Here you give a placeholder name and the picture file, and the placeholder will be replaced by the picture file with the name from the disk. We have already seen table as well. You specify the placeholder and the table data. This is the list of rows, whereas each row is a list again. So you have a list of rows which basically consists of the elements in this row. And then the option arguments, as you can see here, are horizontal header and vertical header, which can be specified too. We have only specified a horizontal header previously in our example. But you can also have a vertical header, as you can see here. So titles, first row, second row, and so on. These are specially highlighted then. We could have done this in our example too. As in the text example, you can also specify a font size. Last but not least, you can also add movies. For example, movies that you have rendered from GeoDict. So, for example, if you render an MP4 video from GeoDict, afterwards you can go and say sl.add-movie and replace a placeholder by this MP4. In this case, this placeholder is called picture, because you can use any layout master which has a picture placeholder. You can replace that picture either by a picture or a movie. So in this case, just use one of the standard slides and replace the picture by this example.mp4. I guess we can agree that we did enough typing for today. So let me show you two more examples that you can just simply run and maybe later use as a reference if you want to dig deeper into it. Let's just go back to GeoDict. Change our project folder once more. Go to File, choose Project Folder, select Project Folder. And here we go to the folder GeoDict Report inside the PowerPoint Reports folder. So Workshop Materials folder, PowerPoint Reports, GeoDict Report, double click, click Select Folder. This is an example. So let's go to Macro, Execute Macro Script. See GeoDict Report, unfolded, maybe click Refresh. There's one utility macro here, which we do not need to care about now. And there are two macros. Step 1, create and simulate, and step 2, GeoDict Report. This basically does the kind of splitting that I talked about earlier. That you have one macro which does all the heavy lifting, which can run overnight or over the course of a couple of days. Then you have a second macro which collects this data and creates a report from it. So you can easily change the second macro and run it again within seconds to just change your report. Or know that you can also record the session macro running these scripts and combine them into a new macro too. This folder already contains the result from step 1. So I would like to ask you to just run step 2 here. You could also run step 1, but it takes a couple of minutes. So let's just go and click step 2 and run it. Now we go to the Explorer again, go to the Workshop folder, PowerPoint Reports, and then the subfolder GeoDict Report that we changed earlier. Here we can now see a new PowerPoint file called GeoDict Report. This again consists of 2 slides. The first slide compares 3 different structures, as you can see here. These are grain structures with different salt volume fractions, 10%, 40%, 70%. And it computes streamlines. It computes the flow velocity through it, and then it renders streamlines which show how the flow wanders through the structure basically. You can see that the velocity on the right side is reduced because the dark blue corresponds to a slower velocity in these denser structures. On the second slide, you can see a plot of the pressure drop along the Z layers and again the table of SVP versus total flow permeability. These plots here are basically produced by the flow solver itself. So if you have a single flow simulation, you get a pressure drop for that structure, which is a single curve here. But you can also combine these curves by combining the GDR results for 3 different flow simulations. Then you can lay them on top of each other. I can show you this in GeoDict. Go to File, Open Results. So you go to this GeoDict Report folder. Should already be there actually. We open all these Lear-Stokes result files at the same time. So Shift-click to mark the whole range to open them. We see the result viewer. We can select them all and click Combine Results here. Then just click OK. We get a new GDR file and the plots in this GDR file, they contain the combination of the corresponding plots from the individual files. So if you go to single file, let's say to the 10% one, go to the plots, we see one single pressure drop curve. Again, for the 40%, same thing, pressure drop along set, and 70%. But in this combined GDR, we'll see all of them layered on top of each other. If you do this, if you combine this GDR, and then you save this image here as a plot, the whole thing will be recorded in the session macro, as I showed you in the beginning, and you can copy that to your Python macro and do the same from within Python. That is what this file does that I showed you, the step 2 that we ran. Now there's one last example that I would like to show you that you can just run again, similar to the one before. Now once more, we change the project folder. So we go to File, choose Project Folder, select Project Folder. Before, we were in FlowDict Report. So we now go back up once to PowerPoint Reports, and go into Filter Efficiency Report. Double-click and select Folder. Now we go again to the macro execution dialog, Execute Macro Script, and unfold the line with the current folder, Filter Efficiency Report, and again we have two scripts, Step 1 and Step 2, with the same split that I showed you earlier. So Step 1 does all the heavy lifting, the computation, and Step 2 then just collects the results, aggregates them, and generates a report. Again, we have the results for Step 1 already present in this folder, so you can just select Step 2 and click Run, please. What this does, it generates again different grain geostructures, but in this case all these structures have the same solid volume percentage. They have a mix of two different grains, a small grain type and a bigger grain type. And the only thing that we are varying is the proportion, the volume proportion between these two grain types. Then we analyze the effect that this has on the filtration efficiency. So after running this macro, go to the Explorer again, go up to PowerPoint Reports and go to Filter Efficiency Report, our new project folder. There you should see FilterDict report.pptx. Double click it, and as you can see again, we have a report with two slides. We have 5 different structures here, where we can see that we have small grains in green and thicker grains in red. We are varying the proportion of these grains. So the red grains are 30 microns and the green grains are 10 microns. To the left, we have 100% 10 micron grains. And on the other side of the scale, we have 100% 30 microns grains here. Due to different coloring, you can see how the proportion varies here. We've also sliced away half of the structure, so you can see how well the particles penetrate inside the structure. You can see here on the left-hand side that when you have 100% of the small grains, then, as one would expect, the particles do not penetrate very deeply. But we can see that the smaller particles penetrate more deeply than the bigger particles, which immediately form a cake on top of the grain structure. If we then increase the amount of thick grains and likewise reduce the amount of small grains, we can see that the particles penetrate more and more until we only have the thick grains, where even relatively large particles penetrate relatively deep into the structure. And we can see that a lot of particles are not filtered anymore, whereas in the first example, we can see that most of the particles were filtered. To get a numerical representation of that, we can also do a plot. Here, we can see the pressure drop of the filter medium, depending on the fraction of large grains. So, corresponding to these structures, 0% large grains on the left-hand side and 100% large grains on the right-hand side, we can see how the pressure drop changes. As one would expect, the fewer particles are filtered, the more the pressure drop decreases. More interesting, down below, we can see the filter efficiency curve depending on the diameter of the particles. We can see that, of course, as one would expect, for the very large, the largest particle, all of the structures basically have the efficiency of 100%. When it comes down to very small particles, then only the structure which has only small grains is able to filter any respectable amount of these very small particles, and all the other structures let a lot of these particles through. At this point, let me just briefly touch on some further topics that were outside of the scope of this workshop, but might be interesting to you. First of all, we usually have a GeoDict-centric approach writing these GeoPy macros, which means that we have GeoDict running, basically controlling the whole thing. But if it's fit better to your workflow, it is also possible to run GeoDict on a command line. give it a macro and set some values for the variables. You could have a Python macro with several variables. Again, please see the beginner's workshop for how to use them, which you can specify from the outside, like using GeoDict as part of a pre-existing workflow, for example, in a batch file or in a shell script, or even calling it from another Python script. That is also possible. There's a lot of other GeoDict API functions, which you have only seen a few of here. These are the functions which start with GD dot, which actually are the core, if you will, which differentiate GeoPy from normal Python. Namely, a normal Python interpreter does not provide this GeoDict API. These APIs allow you, for example, to access the structure itself, to access the voxel image, and the simulation volume fields. So, for example, the velocity vectors or the absolute velocity in a volume field, and it does so with a relative high performance because you get access via NumPy arrays, which allow you to quickly do computations, for example, on these images. You can also manipulate get objects, as we call them, which are the analytical object. So, for example, if you generate a fiber geostructure, you not only have the voxel image, but GeoDict also still knows the underlying fibers. Basically, like a chain of cylinders, if you will. You can manipulate these objects, therefore update the voxel image as well, and also create new objects if you want. You can create and edit all of the object types that GeoDict can create. You can also write, for example, image filters for import geo in Python using NumPy. Now that you can access the help function, which gives you a whole list of functions which you can use directly from GeoDict. In the macro execution control itself, there's a GeoPy API help button. If you click that button, it should open an HTML file which shows you a quick overview of the functions that you can use in GeoDict. These are growing every time. For example, let's see MessageBox. It is the one we used a lot here. MessageBox, you can see the parameters of the function and the type. It takes text, a string, and what the function returns. It returns nothing. And here a quick description of what the function does. You should probably, if you are interested, have a look at this list and see if there is anything that you can use. Beyond that, we also include some additional libraries in GeoDict, namely NumPy, which, as I said, allows you to do fast numerics in the style of MATLAB. So basically, matrix vector style operations, for example, to run statistics, field manipulations, or mathematical operations on result fields. Or SciPy, what we use during this course, which is basically built on top of NumPy and gives you even more math for scientific computations. Then, of course, there's Matplotlib, which we used here too. Again, you'll find a lot of documentation about all of these libraries online, especially for the first three here. Then there's XLS XWriter, which allows you to create Excel files pretty easily. And TensorFlow library, which is a deep learning library, which we'll also use for FiberFind AI and GeoDict AI. And then there is PIL, or rather Pillow, depending, I think it was renamed at one point, which allows you to do image manipulation. For example, you can do a collage of several plots, images, or something if necessary, or several 3D images and put them next to each other or crop them or whatever you want. So in conclusion, we have shown you how you can access your simulation results programmatically using GeoPy, how you can reconstruct your GeoPy code into functions, so you can call it repeatedly from within a loop, for example, and how you can perform a simple automatic material optimization using SciPy. And last but not least, how you can create plots and how you can create PowerPoint reports based on your simulation results. With that, I would like to thank you for your attention. We are now going live, where I will be happy to take your questions for the remainder of our workshop time. Thank you very much.